Hello one and all, welcome back to GIT335 Computer Systems Technology. I, once again, am your instructor, Nicholas Lindquist. Today we'll be breaching Chapter 8 in your textbook, which is the era of big data, databases, information systems, and artificial intelligence. Our topics will include files and databases, and big data, information systems, and artificial intelligence. So as you can see here, big data is a term that means a repository of data that is so large and complex that it cannot be processed using conventional methods, such as ordinary database management software. Some experts expect data to grow by 20 times between 2012 and 2020. As we speculated in previous previous chapters, big data refers to the data that is collected on each of us as we peruse the internet or Facebook or whatever it may be each day. Our browsing habits, our purchasing habits, all of that information is collected in millions and millions and millions of different databases that details every possible digital information about our lives. So that's one form. Another form would be what the CIA or the NSA is compiling on all of our cell phone records, all of our text messages, all of our everything. Everything we do leaves a digital footprint, and all of that big data about us and everybody else is saved in these huge, legendarily large databases that there's so much data we can't even make sense of it all. So now data mining algorithms are becoming a big deal as companies find ways to dig for meaningful clues and associations in all that big data. So big data is so large and complex that we as fragile human beings with our meager minds can't even make sense of it. So we have to employ data mining software. Some basic concepts on managing files. So a database is a logically organized collection of related data designed and built for a specific purpose. A big portion of databases is helping websites to remember. Anytime you go to a website and interact with it in any way, shape, or form, you are sending information to a database which is updating its fields basically based on your input. So in order for a website to have any memory that you were there, information has to be taken from you, the user, and saved and overwritten into the database. So every website that actually does any real thinking or processing has many databases behind the scenes containing information. And as we say here, data is stored hierarchically for easier storage and retrieval. Different databasing terms, including a file or a table, is a collection of related records. A record or a row is a collection of related fields, and a field is a column, a unit of data containing one or more characters. So if you think about this, we're all familiar with databases. A record would be a row. So if we think of maybe like a medical entry in a database, each of us would have a record, which would be a series of rows with information, yes, no, perhaps, or information about our patient history. So each of us would be a record in that database, where a field would be like at the top of the database, the columns that say like has pancreatitis, yes, no. Each of those would be a different column. Blood pressure, this thing, that sort of thing. So records are the horizontal and fields are the columns, the vertical ones. And then, as we've said many, many times already, a character is a byte, which is either a 0 or a 1. I'm sorry, a byte is a collection of 8 bits, and a bit is either a 0 or a 1. So the key field, or primary key, is the field in a record that holds the unique data and identifies that record from all the other records in the table and in the database. A good example for me is, once again, going to that medical example. Whenever I call my doctor for any reason, they ask me what my patient number is, and that is the key field in my database. And once they have that number, they can call up my database and know everything else about me, but that is the unique primary key that identifies me within that massive medical database. So database management systems are software programs that are used for maintaining and culling through all of that big data. So the purpose of a software database management system, or DBMS, is some of the benefits are listed here. Reduced data redundancy. You definitely don't want redundancy in your data, making your database bigger and more unwieldy than it needs to be. You definitely want it sleek and streamlined so that you can collect the data that you want from it when you run reports quickly without getting any redundancies, that sort of thing. Again, we see speed, improved data integrity. It's a big thing in databases. When you update something in one record, you want it to update all of the other records that are tied to that one at the same time. Otherwise, you have incomplete information or incorrect information. So improved data integrity, having that interconnectedness where you update one place and it updates all those other fields as well. Timeliness, ease of sharing, obviously that's important. So we talk about database servers in that maybe a group of 10 or 12 people all working at the same bank or something like that. We'll have a check-in, check-out software running to where when someone downloads the database or is working in it, it updates it on that central file server so that everybody gets those changes in real time instead of passing a file around via email. This is a much smarter way to share and collaborate and get updates on that particular database. So some principal database components include the data dictionary, which is a repository that stores the data definitions and descriptions of the structure of the data and the database. That's basically like the table of contents in a way of the database. Then we have the DB database management system utilities, which are utilities built into that software that allow you to maintain the database by creating, editing, deleting data, records, and files, manipulating that data, streamlining that data, and setting up smart rules that facilitate retrieving the data you want more quickly. And then a report generator when you want to inquire. Going back to our medical example, someone could run a report saying how many of our patients at this hospital have one leg. It's maybe not the best example, but you could run a report and it would show every entry in that database of people who have had a leg amputated, for one example. So it's for culling through that data and bringing back a report to the management or whomever, the owner of the database, in response to the request for specific information. A DBA is a database administrator. This is probably a well-paid gentleman or lady who coordinates all the related activities and needs for an organization's database. These people tend to be very important and key in the IT department of a given organization. The task of a database administrator is to ensure that a database is recoverable, integral, secure, available, reliable, and running at an optimal level of performance. Different database models include the hierarchical database, which is the oldest model of database. Fields or records are arranged in related groups resembling a family tree with child records that are subordinate to parent records, which is low-level records subordinate to parent high-level records. The root record is the very top parent record, the very, very original from which all the other ones sprang. Is, as it says here, the oldest and simplest sort of database. There have been numerous improvements to the database tool standard since the 1970s, and we'll talk about some of those improvements shortly. However, it is still used in some legacy reservation systems, like if you call a hotel or something like that, because they don't necessarily need some of the features and improvements and some of the more powerful data mining tools that come with today's DB database management software. Some of these older hierarchical databases, in the same way that old Fortran COBOL code is still used by some of the old organizations, banks or whatever, that have applications made in that old legacy code. It's still the same way with these databases. They're working well enough, so if it's not broke, don't change it. However, they are relatively rigid in structure and difficult to update. A network database represents a more complex data relationship. Instead of just comparing one field to one field, you can actually compare links to all sorts of different fields, and it creates new relationships in improving database performance and imposing a database standard throughout your database document. Similar to a hierarchical database, but more flexible, in that each child record can have more than one parent record. These are used principally with mainframe computers, and they require the database structure to be defined at the outset in advance. The flexibility for these network databases is still lacking. The relational database is the continued evolution of the hierarchical and network database models. And the relational database works through relating or connecting data in different files through the use of primary keys or common data elements to tie them together. In the same way that there are links in the World Wide Web that tie documents together, the relational database works the same way. The elements create links to one another and better I guess you could say, networks of related data can be assembled and grouped together. So data stored in tables or rows and columns are parts of relational databases, more flexible than previous models, typically built with SQL, which is structured query language, which is a coding language that is used to send requests to the database for information, to retrieve information from the database, and to store new, updated information in the fields of that database. SQL, structured query language, maybe you've heard of SQL poisoning. There's actually ways that hackers can use SQL to inject bad information into databases, which can be a nightmare for database administrators. We'll talk more about that in a little bit. Examples for these large systems, I'm sure that you've heard of these companies: Oracle, Informix, Sybase. And these are the perfect database to use when it's not necessary for the users to know the data structure to use and access the database. An object-oriented database is an even more highly evolved, so to speak, form of database in that it uses objects, which is software written into small, modular, reusable chunks as elements within those data files. Now, rather than just having small text fields, these objects consist of data in any form, including audio, graphics, and video. It's a smarter database that can hold different types of information. Rather than just looking for text, you can upload various audio, graphic, video files, and the database won't blink. It will just accept that file and place it in the place that you have requested. This model is known as a multimedia database. Types include hypertext database and hypermedia database, and those can be links as fields in that database. Data mining. Data mining is the computer-assisted process. As we said, this is software. Very, very smart software programs that cull through massive amounts of data and look for connections, look for new patterns, things that perhaps the humans haven't even thought to look at. So for instance, one of the interesting stories that I like is the young teenage girl who went to Target, and apparently she was buying a pregnancy test or something like that, and some of her other purchases. And so the data mining software at Target that was going through and looking at her purchases figured out, like, hey, she's acting like maybe a person who is pregnant. So they sent her family at home, they sent a Target coupon saying, hey, we think you might be pregnant. Here's some coupons and things that might help you out. So looking for relationships between what this woman, this child, this 16-year-old girl purchased is what clued Target tipped off her parents. And so they found out through Target sending these "you might be pregnant" coupons. So that's kind of what data mining is, looking for connections that human beings either don't have the time to look for or haven't thought of. And so data mining software is getting smarter and smarter in an effort to find these connections. Because as you can imagine, these connections are very, very lucrative. So right now, I'm sure you're probably familiar with the smart grocery cards that we have when we go, and they keep track of our discounts and everything that we've purchased. And we've been doing that for probably 10 or 15 years now. And a very, very big data mining area right now is figuring out what the heck to do with all that data. So these companies know what we've been buying for the last 10 years, but they don't know quite what to do with all that data. So there's a rush to find something useful, some useful way of culling through that data and bringing some kind of useful information from that. As you know, we turn data into information in this class. Raw data into useful, usable information, and a good data mining program will do that. Methods for searching for patterns in the data and interpreting the results. We have regression analysis and classification analysis. Regression analysis develops mathematical formulas to fit patterns in the data that has been extracted. The formula is then applied to other data sets of the same type to predict future trends. This is a little bit less smart of a way of culling through that data than classification analysis, which refers to statistical pattern recognition that is applied to data sets with more than just the empirical numerical data. Moving on to the next section, big data, information systems, and artificial intelligence. Big data aims to tap all the web data and other data that is outside of corporate databases. Big data typically means applying the tools of artificial intelligence to vast new sources of data, beyond that captured in our standard databases. The new data sources include, as we discussed earlier, web browsing data trails, social network communications, sensor data, and surveillance data. So big data is all that data that we so willingly hand over to the internet without really caring and without realizing, of course, that we are creating extensive online personas, databases full of information about ourselves. And so all those other companies that are hungrily snatching up all that information that we have provided are looking for ways to tap that big data and create meaningful money-producing associations for themselves through that. So as you can see there, that's done through the web browsing data trails, social network communications, sensor data, and surveillance data. The rather innocuous data that we don't really seem to mind turning over in exchange for free services. The saying that I like is, if you don't see what's being sold, then you are the thing that's being sold. So why is Facebook, for example, free for us? Obviously, they're not doing it just for charity. They're making a lot of money and selling us. We are the product when it comes to Facebook. All the information that we share is shared with third-party outsiders. So just something to know, and then God forbid, should you actually chronicle or post about how you're committing illegal activities, you should know that the government routinely subpoenas Google, Facebook, other big data sources like that for information on specific people. So it just makes good sense, guys. If you're going to be a criminal, don't tell the World Wide Web about it, because that data is not safe. Just because that post is private, don't think that it's not subject to the subpoena from the government. The evolving world of big data. As we said here, 3 implications of big data. 1, big data derives from a bundle of old and new data sources. The new data sources are the ones we just described: web pages, sensor signals, etc., etc. The old data sources may very well be like the grocery store smart cards that we were just discussing. Big data could, I think it's safe to say it will, lead to a revolution in our current measurement of statistics. The volume and variety of data, along with powerful new smart softwares, could revolutionize how things are measured, just as the invention of the telescope opened up the heavens and the microscope unveiled the mysteries of biological life down to the cellular level. So in other words, it's expected that big data will change the world when we figure out exactly what we want to do with it. Basically, when they figure out how to make a lot of money off of it. Big data could lead to better decision making. In fact, I think actually that's also a certainty as well. Not only can data-driven insights be used to make sense of incredibly complex situations, big data can help compensate for our overconfidence in our own intuitions and can help reduce the extent to which our desires distort our perceptions. The old saying is that you see what you expect to see. So when we look out into the world, we see a reflection of what we have on the inside. And for that reason, we can become biased to our own preconceived notions. And big data will help us lead to, ultimately, to better decision making, in that we won't have that bias towards things that we already think that we know. In short, big data is a term for a process that has the potential to transform everything. Uses of big data, it's key for the current moment in finding major uses in medical research, marketing, politics, and even entertainment programming, to name just a few areas. Information systems and organizations. An information system is a combination of people, hardware, software, communications devices, and databases that provide data and information for a specific purpose. So an information system, once again, would be like a perfect example would be that Wells Fargo where the 10 to 12 people work, all have a shared information system that helps them, facilitates them to actually do business. So examples, qualities of good information are that it is correct and verifiable, it is complete yet concise, cost-effective, current, and accessible. Most organizations have 6 departments within which information must flow. Horizontally listed, these organizations are Research and Development, R&D, which is apparently the most important of all of these, according to a entrepreneurship professor that I've been talking to recently. R&D is by far the most important of these. Anyway, production, marketing and sales, accounting and finance, human resources, and information systems at the top of that. So besides those 6 departments, many organizations also have 3 levels of management, and this is where the information flows vertically. Strategic level management is the very top dogs, the top managers that are concerned with the long-term or strategic planning and decisions. Basically, they want to use that big data to guide the ship. And then we have the tactical level middle management, which is those TPS report assigning type of guys who always want us to come in on Saturdays, right? These are the middle level managers who make tactical decisions to implement the strategic goals set for the organization. They are the middle level managers who just kind of follow the course that's been set by those top-level managers. And then the grunts, the peons, the operational level management that so many of us are those low-level supervisors who make daily operational decisions and try to stay out of the way of the top managers and the middle-level managers. The new information flow is decentralized organizations, creating networks of information instead of top-down silos. The pyramid management structure is flattened somewhat. As employees are given more authority, they are being empowered to make their day-to-day decisions. Employees are increasingly linked to a central database, as we talked a little bit earlier about that check-in, check-out central database program. A software program such as Groupware, CSCW, computer-supported cooperative work, enables lots of people to work on a number of digital documents all at the same time without doubling up on their efforts or without updating old code, whatever it may be. Groupware, computer-supported cooperative work, facilitates that interconnected modern working environment. And additionally, many people can work together from different locations to manage that information. Computer-based information systems include information systems that are a combination of hardware, software, and telecommunications networks that people build and use to collect, create, and distribute data. These include office information systems, transaction processing systems, management information systems, decision support systems, executive support systems, and expert systems. Let's talk a little bit about each one of these. The office information system, also known as an office automation system, combines these various technologies to reduce the manual labor required to operate at an efficient level in the office and to increase productivity. So these are database information systems that are used to increase office productivity, increase the bottom line, whatever that might be. Here's some different examples of office information systems. We have the electronic publishing system for word processing documents, desktop publishing, whatnot. Electronic communication systems, that all-beloved email that we all love so much. Electronic collaboration systems, Google Docs, whatever it may be, teleconferencing, web conferencing, whatever. Image processing systems, those signing PDF documents, all that sort of stuff. Check images, whatever it might be. Those important presentation graphics would all be housed in this type of environment. And then office management systems, such as the electronic office accessories, those all important electronic office accessories, and task management, that sort of thing, all fall under office management systems. Office information systems, Next we have transaction processing systems, which are used to aid in the buying and selling of goods or services. As we actually joked a few slides ago, the TPS systems, we have those TPS reports. Those are a real thing, believe it or not. So TPS systems keep track of the transactions needed to conduct a business, and you should always remember to fax a cover sheet with each of your TPS reports. That is one of the most important features of a TPS. Management information systems, database information systems used to improve the process of managing employee resources. Decision support system, as I'm sure you can guess, computer information system that improves analysis and helps management focus on the future. Executive support systems. And finally, the expert system, which is also called the knowledge-based system, the set of interactive computer programs that help users to solve problems that would otherwise require the assistance of a human expert. These are systems that pretend that they are human beings as well as they possibly can. And one of the most useful applications of these expert systems is artificial intelligence, or AI. So let's talk a little bit more about artificial intelligence now, shall we? Artificial intelligence is the branch of computer science that is concerned with making computers behave like humans. I'm sure that this is not news to you. And living in our modern day and age, we are definitely used to the idea of artificial intelligence. And each day, our cars get a little bit smarter. Our society in general relies a little bit more on artificial intelligence to take away the dumb, monotonous, day-to-day aspects of our lives that we would just as soon not deal with, to free up our time for the higher brain activities. So artificial intelligence is basically making our lives easier, supposedly. But as we said, each new technology that is supposed to make our lives easier in reality just handicaps us and actually takes up more of our time in that we have to support this whole new system. But anyway, artificial intelligence comes in two forms. Conventional artificial intelligence attempts to mimic human intelligence through logic and symbol manipulation. This is basically, they try their best to pretend that they are human beings and do what human beings do. So that is conventional AI. Would be an example would be a program where humans try to guess whether they're talking to a computer or a robot. And then eventually the robot will make some kind of communications faux pas, and the people will know, okay, I'm talking to a robot, haha. But those robots get better all the time, and that is conventional AI. Then we have computational intelligence, which relies less on formal logic systems and is more about experimental and trial and error methods. This is ways that robots, artificial intelligence, is learning to think better than human beings can think. This is maybe a little bit more scary, in that it is the field where human intelligence will become subservient, second tier, to computer artificial intelligence. So a little bit scary there. That's Skynet, would definitely be computational intelligence, right? Instead of conventional artificial intelligence. So weak versus strong AI, just pushing on that a little bit more. Weak AI makes the claim that computers can be programmed to simulate human cognition, means that humans or computers can become as good and convincing as humans can be, so that maybe a software program can actually help people through that are calling on support calls or something like that instead of a real human being. And then strong AI makes the claim that computers can be made to think even better than we can, and that's the whole Skynet thing, right? So that would be computers learning to think at least equal to humans and possibly even more conscious of themselves and aware of themselves than we are. And at that point, are we even really needed? And then we have like a matrix type situation where we support the machines. Yes, we're actually getting to that point. AI areas include expert system, natural language processing, intelligent agents, pattern recognition, and some of the other topics you see here. Expert systems are built by knowledge engineers, obviously. They include surface knowledge as well as deep knowledge, obviously. And three components of an expert system are the knowledge base, which is the expert system's database of knowledge on a particular subject, the interference engine, which is the software that controls the search of the expert system's knowledge base and produces conclusions, based on the contents of that knowledge base, and then the user interface, as we said at least 10 chapters ago now. At this point, the user interface is the display screen for the user to interact with that expert system. So the knowledge base is the information, that is known, and the inference engine is what is actually used by the engineer or the expert to call worthwhile and useful information from that knowledge. All right, ladies and gentlemen, thank you so much for your kind attention today. It has been a real pleasure talking with you today. I look forward to seeing each of you online, and stay tuned for our last chapter coming up next week. Goodbye.